All right, so I want to take a moment to look at this reasonable minimal number of terms together and actually assess how do we do questions like this where we know it's the harmonic series because we can see that it's adding by 3, at least in particular to this one, to get in between each term. So we know this is harmonic. So how do we figure out how many terms must be added together in order to ensure a sum of at least whatever the number may be, in this case 5. So we're doing that minimal number of terms thing. So once again, may I remind you of before when we were talking about, how do you know that this thing is actually a harmonic series, or how do you actually know that this is going to actually approach infinity? We looked at the same basic scenario here and said, we see that we're going up by 3, in other words, adding. So a better approach would be to look at some multiples of 3. And if you recall back to the time that we looked at this, we said, you know what? We're going to look at multiples of 3, but I need them to be smaller than 1/7. In other words, I can't use 1/3, 1/6, 1/9, because if I did that, these aren't actually smaller but bigger. So we don't want to use that. We're going to use 1/9, 1/12, 1/15, 1/18, and so forth. And as you compare these, we understand that if I can figure out when this will equal 5, then certainly this section, which is bigger, will also be 5. So let me say that again. Once we recognize that 1/9, 1/12, 1/15, 1/18, more typical harmonic series, once we recognize that as being 5, then this set here on the left, the 1/7, 1/10, and 1/13, because those are bigger fractions than 1/9 and 1/12, it must then be 5. And the reason that this 1/9 is easier to deal with is because we can easily pull out that 1/3 and recognize that what I'm dealing with here is 1/3, 1/4, 1/5, 1/6, and so forth. And so what we're basically looking for is when is this thing going to be equal, and it says at least, so greater than or equal to 5 would be a better mathematical way of looking at this, equal to 5. So in essence, what I'm actually looking for, now let's think about this, I need to figure out what does this series have to be. See, I'm doing 1/3 times this series has got to equal or greater than or equal to 5. So what I really need is that this series is greater than or equal to 15. Can you follow that? So using what we've talked about with the harmonic series in the previous couple of days, through the video and then through class, we talked about how we can actually determine how many terms it would take to get to 3 or 4 or 5, or in this case, 15. So let's do just that. What we want to do is set up a pattern, right? And I basically am looking at, I want to get the sum of 1. So the sum I'm looking for is 1, 2, 3, 4, however many it takes to get that pattern, and how many total terms am I actually looking for here. So notice we're starting our pattern here at the 1/3 and 1/4 section, right? And so keeping in mind, our harmonic usually starts like so. Right? And we recognize that we can divide this into the terms that we need, right? And so here we would have 1 term, 2 to the 0. Here would be 2 to the 1, or rather 2 terms total. This would give me, here would be 2 squared, which would give me 4 total terms, and so forth. So if I want to get 1, I would need, and since we don't have these, let's think through this, I would need this section and this section to get 1, and that would be at 2 cubed. Notice, though, we're missing 2 terms, so I would say 2 cubed minus 2. Okay, let's do another one. Then to get 2, I would have to go up 2 more, so that would be 2 to the 5th, and again, we'd have to subtract 2. Are you still with me? And then I would need 2 to the 7th minus 2. So if I want to figure out what it would be at 15, how do I link the power here with what the sum actually is, so that I can go right from the sum to knowing what this is supposed to be right here? Okay, so that's really what I want to do. I know that what I need to do is figure out what that is. So here's we understand this as odd numbers, right? And if you think about it as 2 times the sum, I don't know what I'll call, I guess I'll use S, plus 1. Does that work for all? 2 times 2 is 4, plus 1 is 5. 2 times 3 is 6, plus 1 is 7. It works. So to figure out what K is, we would do 2 times 15, which would be 30, right? Plus 1. So it would be 2 to the 31st minus 2. Take a few times and look through that video so that you can actually understand what just happened there. And we'll pick up here with another topic in just a minute. So take a minute, look this over, and see what you find out. I hope you took some time to think through that and maybe even look through that example again. Now you notice I've changed the example a bit, just to do another example for this reasonable minimal number of terms. It can be a little tricky, so I think the more practice that you can see, the better off you'll be. So let's look at this one. 1/5, 1/9, 1/13, 1/17, 1/21, and we want the sum of at least 8. So just like before, you want to think about what the pattern is, but this time, of course, we're thinking about the pattern in terms of addition. We have to recognize what's being added in between each of these. And so this time, what's being added is 4th. Good. So what we want to look, again, is we want to look into comparing between multiples of 4. We don't want to start with 1/4 because 1/4 is actually bigger than 1/5. So what we want to do is we want to compare something that's smaller, because once that smaller piece has arrived at 8, then we know whatever's larger is going to be definitely at 8. So where we're going to start is 1/8, then 1/12, and then 1/16, 1/20, and 1/24. And you can see in comparison, each of these 1/8, 1/12, 1/16, 1/20 is in fact smaller sequentially by the other ones. So now what we will do, again, is multiples of 4. So we're going to factor out the 1/4, and that leaves us with 1/2, 1/3, 1/4, 1/5, 1/6, da da da. And we want to know, when is this at least 8? So greater than or equal to 8. Again, like I did in the previous example, this is your S, right? So 1/4 times S, I want to be greater than or equal to 8. So really, I'm looking for, when is this series going to be greater than or equal to 32? That's really the question that we're looking for. Knowing that, what I need to do is set up a table in comparison of the sum and the number of terms, once again. So just to start, we always start with the sum of 1, 2, 3, and however much you need, so you can set up that pattern so that we can figure out what it will be to 32. And in doing so, we want to compare to the part of the harmonic series that we're actually working with. We are working with 1/2, 1/3, 1/4, 1/5, 1/6, and I'm just going to write out at least a few more, because it definitely helps just to have a perspective of that harmonic series. Remember, this we can basically use as like constant. Normally this is a 1 here, so keeping in mind that that's not available here, so we know that in the end, whatever it is, we're going to be subtracting 1 from each of these because we don't have it starting at 1. So we recognize that this line falls at 2 to the 1st. This line is 2 squared. This line is 2 cubed in terms of the total number of terms. 1, 2, 3, 4, 5, 6, 7, and 8 would be this 1, but that's why we have to subtract the 1. So if I want the sum of 1, that means I'm going to add 1/2, and I've got to add this. That's what gives me 1. This half here, and the 1/3 and 1/4, which gives me another half. That is it. And it falls at this line, which is 2 squared. So that would be 2 squared minus 1. If I want a sum of 2, I would have to add this piece here and the next one. And so that line occurs at 2 to the 4th. So I would have 2 to the 4th in terms of total number of terms to get to 2. And then for 3, I would have 2 to the 6th, right? Now we want to link, from here, you want to link the sum to the power, the sum to the power, the sum to the power, so that I can do the sum, and I know that what this is 2, and we want to figure out what this number is here. And so the relationship you're looking for is what is going on between the sum and that power. And I hope it's pretty easy to see. What I would like you to do is to come in tomorrow with that answer for me. 2 to what power should this be to figure out the number of terms it would take to get at least 8?